So I have this beam, I want to know what the moment is at the end. Well, I got this little notch here, and I don't like it. So what I'm going to do is I'm going to move that 400 over here. But remember, moving something laterally requires what? A compensating couple or moment. So I'm going to put 400 down, and I'm going to put 400 up. What's the net of this? 0. However, this right here forms a, what does that form? A couple. What's the value of that couple? The value of the couple is the moment, which is 400 times 1.2, which in this case is 480. Is that clockwise or counterclockwise? That is clockwise. If you don't see it, let's bring it down here. We can show you. I'm going to grab this arrow. I'm going to grab that. I'm going to pull up and pull down. What do I get? Clockwise. That's how you can determine what it is. So what we're saying is this is now equivalent externally to this beam. I got 400 here. I got a compensating moment of 480. And I have 200 at an angle of 30 degrees. Now I can say, hey, some moments at A, I'm going to take counterclockwise positive, is equal to 400 at A, that's going to be a distance of 3, so this is going to be 400 times 3. There's the force, there's the distance, right? And now this is creating a clockwise moment. That's a negative. This is clockwise. I just add that in, 480. A moment is a moment. You don't multiply it times 8. You just drop it in with the proper sign. Then this guy over here has two components. One this way, which is 200 sine 30, and one this way, which is 200 cosine 30. That one created no moment. What concept am I using here? Huh? Varignone's theorem. Varignone said, hey, if you want to do the components of the force and take moments, by all means, go ahead. And that's what I'm doing. Now, this is going to be 200 cosine 30 times, there's the force. Here comes the distance. The distance from this arrow all the way over here is 8. And that's creating a clockwise, boom, equals, doesn't equal 0. Just, that's the value. So the moment at A is going to be 3065.6 clockwise. Because you're going to get negative, but the negative is the opposite of that. So I'm going to get MA is equal to 3065.6 clockwise. Done. So I just showed you how you can use the lateral transfer theorem to your advantage. Questions on that? So now that brings us to the very last topic of chapter 4 for the test. There's another topic after this, which is distributed loads. But we're not talking about that for the test. For the test, this will be the last topic. And the topic is equivalence. Have we done equivalence before? Have we done equivalence The answer is yes. Where did we use equivalence? We used it when we did resultant. We took two forces, added them head to tail, and got a resultant. The resultant was the equivalent force that replaces those two, which had the same net external effect on the body. So we were doing equivalence from day one. Here, we're going to do equivalence because now we're going to bring in moments into the picture, which we did not do in chapter 2. So now I have forces and moments. And when you take a bunch of forces and a bunch of moments and reduce it down to a single force, single moment, that's called a reduction problem. Every single force moment system can be reduced down to a single force, single moment. Every time. Not just on Tuesdays and Thursdays, all the time. That is a fact. How do I do it? Well, I just simply take the force, if it's an IJK format, and put all the forces in IJK format, then add up I's, add up J's, add up K's. That's it. That's the single force result. What about moments? Well, I do some moments about a point, O, A, B, C, whatever, and I do R cross F, or force times distance, for each and every one of the forces involved. And then I just sum them. If I have everything in IJK format, I add up I's, add up J's, add up K's. There's my single force result. So, this is in the videos. All systems can be reduced down to a single force, single moment. Notice I have a subscript and a superscript. The subscript tells me that's my moment center. You can have any moment center you want. O, B, A, C, whatever. And the superscript tells me this is the resultant of all the moments. Okay? How do I know two systems are equivalent? Two systems are equivalent. They have the same force, same moment. Period. End of discussion. So, if you go back, you did equivalence back in Physics 1. You probably don't even remember. It probably wasn't even pointed out to you that you were doing equivalence. But when you did center of gravity, you have an equation. X bar, Y bar. That center of gravity equation came from that concept of equivalence. So that was an application of equivalence. How many remember the equation? The answer is probably very few, if any. Why? Because you memorized the equation, took the test, dumped it out of your system. That's what you did. That's not learning, by the way. That's a quick memorization and it's not retained. If you understood what it meant, this is what it really meant. You had a system of a bunch of forces. I'm just showing 4. It could be whatever you want. That's system 1. You said, hey, because there's a center of gravity, I'm going to go to system 2. Equivalence says, I can do it. I can go to a single force, and now I got to place that force someplace. Where do I place it? X bar, Y bar, from an XY coordinate system. Well, how the hell did you do that? The answer is, hey, if these two systems are equivalent, forces here must be the same as those forces there. So when I summed all this, I should get W total. Forces here must equal forces there. But what else must be true? If these two systems are equivalent, according to this, you got to have the same moment. How do I calculate moment? Force times distance, force times distance, force times distance. Right? So I got to go in here and do WT times X bar. That's the force, or that's the moment, force, distance, moment of system 2. Because there's only one force, W total, times its distance, it creates a moment. The system 1 has a bunch of W's. W1, W2, W3, W. you take and find force times distance, W1 times x1, W2 times x2, W3 times force times distance, force, and you sum them. And if I want to find x bar, then I take that and divide by W total, I'll get x bar. That's the center of gravity equation. So where is the origin of the center of gravity equation? The answer is equivalence. How do I get the equation? I just said the moments of the reduced system equal the moments of the original system. So it's nothing more than equivalence applied. That's it. And the equation comes from moments equal moments. This is moments of the original system must equal moments of the reduced system. So from this point on, do I really have to memorize what x bar is, what y bar is? Hell no, I just got to remember moments of the original system must equal moments of the reduced. That's it. That's the equation for center of gravity. Okay? Now, the question is, I can always reduce down to single force, single moment. Here's the question of the day. Is there a simpler system than force and moment? Single force, single moment. And if there is, how the hell would I know that there is? So the question is, can I reduce down to, say, a single force? Or a single moment? Let's stick with single force first. What I want is what I call a litmus test. Everybody remember the litmus test from chemistry?
Yep.
In the old days, you took a piece of paper, dipped it into the liquid. If it turned red, it was acidic. If it turned blue, it was basic. Well, I want a litmus test to tell me, hey, when I reduce down to a single force, single moment, can I go down to a single force? That's the question of the day. So I want to develop a litmus test. Here is system 1, and I'm showing 3 forces, 2 moments. You can show however many fucking forces and moments you want. Doesn't matter. I know. I can always go down to system 2. What's system 2? A single force and a single moment. That's a given. How do I find that single force? Add up i's, add up j's, add up k's. How do I find the single moment? Do r cross f, and then add up i's, add up j's, add up k's. I'll get the single moment. The question becomes, hey, can I go from system 2 to system 3? What's in system 3? One single force. It's the force resultant. Well, if these systems are equivalent, forces here must equal forces there, must equal forces there, and also moments there must equal moments here, must equal moments there. The equation is going to come from the moments. So when I look at the moments, that would be the moment P in system 1. This is MPR in system 2. And system 3, we're saying that single force is going to create a moment. What is that moment? It's R cross F. Well, in this case, since I'm taking the moment center at P, it's going to be R PQ cross F. This would be the moment being generated by that single force in system 3. But that moment has to be the same if they're to be equivalent as system 2 and system 3. Agreed? What the hell do I know about A cross B? What do I know about A cross B?
It's a vector.
I get a vector C. What else do I know about that vector C? It's what? Yeah, it's perpendicular to the plane that contains A and B. So this moment has to be perpendicular to the plane that contains these two quantities. Hey, let me ask you this question. Do you have a perpendicularity test?
Yes.
Yes.
What is that perpendicularity test?
Dot product.
The dot product. A dot B equals 0 tells me A and B are perpendicular, correct? So my litmus test is easy. If this is perpendicular to that, If I take this dotted with that, I should get what? 0. There's my litmus test. MP dotted with F resultant, I should get 0. Okay? I told you that this A cross B is going to be perpendicular to vector C. I had you underline it when we did vector cross products, did I not? That's why. So, my litmus test then comes down to this. MP resultant dotted with F resultant must equal 0 if system 3 is to exist, which means a single force. Wow, that's cool. That's pretty powerful. Now, if I have the capability of reducing it down to a single force, the question then becomes, where the hell do I place that single force so that I generate the same moment as was in system 2? Everybody understand that? I got to take the force and place it someplace so that force will generate the same moment that was in system 2. So, if I say, find me that location, this is the system 2 moments. If I then take system 3 and say Rx, Ry, Rz, Fx, Fy, Fz, and do the cross product, and then equate this moment with the i's over here, the j's over here with the j's over there, k's over here with the k's over there, I will locate Rx, Ry, and Rz. That's how you find it. Okay? Now, this all is out in space and conceptual. When we do the first problem, we're going to get down to the nitty-gritty, and you'll see what I mean. Now, how many have seen this video? You've seen it. All right. Tell me, there are 3 systems that automatically reduce down to a single force. Automatic. I don't even need the litmus test to decide if it can go down to a single force. Name one. You saw the video, you said. You a while ago. So you're ahead and now you forgot. Of course. Anybody? What? Pulleys. Where the fuck did you pull that out of?
I'm just guessing. I don't know what to do.
Let me pull pulleys out of my ass. Go ahead.
I cross I equals J cross J equals K.
Nope. What? If the systems are concurrent, guess what they were back in chapter 2 when we did the resultant? The 2 systems were concurrent. I was able to take the 2 forces, reduce it down to a single force. Remember doing that? So a concurrent system will always reduce down to a single force. Give me another one. Coplanar systems will always reduce down to a single force. The third one. Go ahead. Do you know it? Parallel. She saw the video. So 3 systems that always reduce down to a single force are 1. Concurrent. 2. Coplanar. 3. Parallel. I don't even need the litmus test to tell me I can do it. I know I can do it. But the litmus test will verify it if you want it to. Okay? So, think about this. Makes a perfect quiz question. List 3 force moment systems that reduce down to a single force all the time. 1, 2, 3. On a quiz. It's not hard. There it is. We just covered it today. So don't be shocked if it happens. Okay? Now, what is the simplest system you can generate? Do you remember? You saw the video. Who saw the video? What's the simplest system you can generate? The answer is called a wrench. I don't like to use the word wrench, but I understand why they use the word wrench. I like to use screwdriver. Why? Because when you put a nail or a screw in here, you take your screwdriver and you push. So the force is going this way, but then you also turn to screw it in. But when I turn this way, there's my resultant moment. So I have a force that's going in here, and a moment. Notice the two are parallel. There's the force, there's the moment. The two are parallel to each other. That's the definition of a wrench. A force and a moment that are parallel. That's the definition of a wrench. So if you look real closely, definition of a wrench. Force parallel to a moment. I like to call it the screwdriver because it gives me a better visual interpretation. Now, here's the possible outcomes when you reduce. 4 of them. Number 1, if the sum of the forces equals 0, the sum of the moments equal, there is no resultant. The object is in equilibrium. That's chapter 5. That's coming up. Some of the forces equal 0, but some of the moments don't equal 0. You literally have a moment result. There is no force. The forces are summing to 0. If some of the force is different than 0, some of the moments equal 0, single force resultant with F being perpendicular to F. And lastly, if these guys are some force different than 0, moment and F and M are parallel, you reduce down to a wrench. These are the 4 systems of reduction. Okay? How do I know 2 systems are equivalent? How do I know 2 systems are equivalent? Forces in the first must equal forces in the second. Moments in the first must equal moments in the second. That's it. It ain't that fucking hard. Right? So, let's do the first problem. I'll come back to these. I want to do one that hits home right away. And it's this one on page 66. So here I have 5 forces. Physically outside the real world, we'll consider them as 5 columns sitting on a slab. Right now it looks like force 1, force 2, force 3, etc. But physically, outside the real world, this could be a bunch of columns that are stationed on a concrete slab. And the question now is, hey, what is the resultant force, moment on that slab? What is the force resultant and moment resultant on this slab? And, hey, can I reduce this? Because remember, all 4 systems can reduce to a single force, single moment. The next question says, hey, can it be reduced any further? Can I go to something simpler than a force and a moment? Can I go to a single force? Well, this is a, what type of system? Shit, this is a coplanar and parallel system. Those are always going to go down to a single force, correct? So, here we go. We're going to reduce this down to a single force, single moment first. So, to make my life easy, I'm going to go over here and say, this is my R, this is my F, this is my moment about O, which equals R cross F. And I'm doing it about O because it asks me to do it about O. So, here are the forces. Minus 600J. Minus 2000J. Minus 500J. Minus 1000J. And minus 700J. I'm going to sum this. This will be my force resultant. I'm going to sum this. This will be my moment O resultant. Well, if I sum these, I'm going to get minus 4800J. That's my single force resultant. That was really hard. Let me tell you what. Man, you're exhausting me with this shit. I can get a damn 7th grader. Hell, I can do a 5th grader to do this for me. summing these forces. That's it. Moment. I'm going to take moments about O. I need an R. So here's O to the 500 to the 600. We're going to go from O to there. What is that red R? 8 what? 8I. Okay, so this would be 8I. Now I got to do 8I crossed with minus 600J. Let me remind you of my little gizmo IJK. So I'm going to take I crossed with J, so I'm going this way. IJ, the next letter over is K, and since I'm going this way, it's a positive, but there's a negative, so I'm going to say this is minus 4800K. Any problems? 2000. Well, the 2000, I'm going to go this way 6, and then this way 4. So technically, I'm going to do 6I plus 4K. So literally, I'm going to say 6 times 2,000 is 12,000, and 4 times 2,000 is 8,000. And I'm going to use my little gizmo here to say, hey, I crossed with J is K. K crossed with J is a minus I because I'm going this way. So in the long run, I should get 8,000 I minus 12,000 K. Agreed? Really? We're going to go there? You don't like that? That's fine. I can do it an alternative way. I, J, K. What's my R? 6, what I say? 604. And then my force is 2,000J. 0 minus 2,000, 0. Extend the 2 columns over, 6, 0, 0 minus 2,000. That's 0. That's 0. This is minus 12,000K. That's 0. This is 8,000, but since I'm going this way, I'm going to put a negative. Negative, negative makes it a positive 8,000 I. That's 0. Did I prove it for you? You're going to question that again? You got to do the cross product, ladies and gentlemen. You with me? It's math. And it ain't even got to do anything to do with statics. We're on this side of campus. You can't do the math. Business school awaits us around the corner, down the hall over there. Okay? Let's be real. Okay. Next, I'm going to go to the 500. From O to here is how much? 7 what? K. Crossed with this, that's going to be 3500I. Yes? 7 times 500 is 3,500. K cross J. K cross J. The next level over is I. Since I'm going clockwise, I got to put a negative. Negative, negative makes it a positive. Next, minus 1,000. That's going to be 2I plus 8K. Result here is 8,000I minus 2,000K. And then the 700, that's going to be 10I plus 10K. Do the cross product out, you'll get 7,000I minus 7,000K. Add up I's, add up J's, add up K's, you will get 26,500I minus 25,800K. So, my single force resultant is minus 4,800, downwards 4,800. My single moment resultant, this is my moment about O, resultant. The superscript tells you it is the resultant of all the forces, or all the moments. 26,500 I minus 25,800 K. What the hell does that mean? Well, if you look at your coordinate system, here's your coordinate system. I'm going to put my thumb along the X and I'm going to curl my fingers. That's the 26,000. And the K, I'm going to put this along the negative because it was a negative 25.8. And I'm going to curl my fingers around that way. Now, litmus test time. Litmus test. Does F resultant dotted with MO resultant equal 0? That's the question of the day. Is it? Well, what's J dotted with I?
Okay.
What? What?
Yeah, negative.
J dotted with I is what?
A negative K.
Can I shoot you now or shoot you later?
Okay.
I didn't say cross product, I said dot product. What survives in a dot product? I with I, J with J, K with K. Any other combo is 0. So when I say J dotted with I, what do you get?
0.
J dotted with K, what do you get? So does the litmus test work?
No.
Yes! It is equal to 0. Yes! Therefore, can reduce to single force. Can reduce to a single force. Oh shit, I can. Holy crap. How do I get there? What is the single force? Negative 4,800 J. That's the single force. Now the question is, where the hell do I place that force on this slab? So here's a pictorial of what we've just done. So this is the slab system 1. I got forces here, forces there, etc. I got 5 of them. This, now we said, is equivalent to a single force 4800 with a moment along the X, which we said was 26,500, and a moment along the K direction, which was 25,800. That is system 2. We are guaranteed system 2 always. I'm guaranteed to always reduce a system of forces and moments down to a single force, single moment. That's system 2. We just did the litmus test, and we really didn't need the litmus test because we said, hey, there are 3 systems that were reduced down to single force every single time. I don't need the litmus test. What were they? Concurrent, coplanar, and parallel. Well, this system we just worked with is coplanar and parallel. We got a double win. So now, I'm saying to you, oh shit, there is a system 3 right here that says I got some force, one single force, 4,800. I just need to find this distance, which is x, and that distance, which is z, because it's in the xz plane. So I need to find a force somewhere in the xz plane, place it there, that will do what? That will produce the same moment that I see in system 2. So there's a place. Think of this as the plane. I can put the force here. I can put the force there. I can put the force over here. I can place that force 4,800 anywhere in this plane. But I got to find the right place. What is the right place? The right place is the one that produced the same moment that you see in system 2. So how do I do that? Well, now I'm going to say this to you. What is the moment here? The moment in system 2 is, moment O resultant is 26,500I minus 25,800K. Agreed? That's the moment being generated. This must equal to the moment here. Well, what is that moment? This moment is x, 0, z, and this force is 0 minus 4,800 and 0. This is the moment in system 2 must equal to the moment in system 3. That moment in system 3 is going to be generated by that single force of 4,800 downward. I just got to locate it somewhere in this plane and put it there. The location of that point has to generate the same moment that was in system 2 if the two systems are equivalent. Yes? You with me? Who's not with me? Does everybody understand what I'm doing? Yes. Litmus. Litmus. Did you not have chemistry? Did they not do a litmus test in the lab? I don't remember. Okay, what's the question? Litmus test. Yeah? It covered it all already. I don't even need to use the litmus test on that. Already there. Yeah. You with? Are you guys playing Hansies? What's he playing? I minus 25,800K is equal to, if I do this cross product, which you should know how to do, right? You're going to get minus 4800XK plus 4800ZI. Now I just simply equate i's. 26,500 is equal to 4,800Z. Z is going to come out to 5.52. K's minus 25,800 must equal to minus 4,800X. X is going to equal to 5.375. So now I have a location where to place the damn force of 4,800 downward so that the slab externally, if it was a touchy-feely slab, couldn't tell the difference between 1 force and 2 moments, or one single force placed at 5.3750 and 5.52. So this here has to be 5.375. This has to be 5.52. And these three systems are externally equivalent. The slab cannot tell the difference between any of the three. Externally. I never said anything about internal. All three are internally totally different. Okay? This is all external, not internal. Internal is a whole different animal. Any questions there? Yeah.
Could you explain the IJK thing, the holy thing?
The fully thing?
No, the circular one, where you like up top?
You mean the gizmo?
Yeah, exactly.
IJK. You've never seen the gizmo?
I just want to refresh on
So if I say 2K crossed with, say, 1J, right? This is 2 times 1 is 2, but now I got to give it the IJK thing. So I look at it here and I say K, the next letter over is J, the next letter over is I, so I know it's I. And then since it's going clockwise, not counter, because counterclockwise is positive, clockwise is negative because of the right-hand rule, that should give me a minus 2I. If I say I crossed with 5K, I crossed with K, from I to K, then the next letter over is J. Since I'm going clockwise, that's got to be a minus 5J. If I say K cross 2, or 2K cross with 2I, that's going to be 4. K cross I, next level over is J. That's going to be a plus J. You get it?
Yeah, thank you.
Any other questions? All right, let's go back now and pick up this guy. Does everybody understand this? This is huge. Okay? Let me have the This is huge, and this is huge because question number 3 on every statics test that I've ever created has this. Now, question number 3, question number 2 are already done for the test. I am working on question number 1 right now. So question number 3 is done, along with its diagram. I'm going to tell you right here, right now. Do you see the damn words? They ain't changing. Now, it may say instead of DE, do it about AD or CE or whatever the hell I decided. And it's going to have different forces and different moments and stuff, right? Other than what you see here. So there'll be different forces and moments, but it's going to say exactly the same thing. What's the first line? Hell, I don't even need to read the question. I can tell you. It says, express all forces and moments in Cartesian vector form. Give me freaking IJK. That's question number 1. Question number 2, find me a moment about A. Find me a moment about the x-axis. Find me a moment about the coordinate axis. Something about where you have to calculate R cross F. It doesn't matter what the force is. It could be force 1, force 2, force 3. It's some force that I'm going to designate. Question number 3 of the problem number 3. Hey, tell me the component or project this force, no matter what the force is, F1, F2, F3, some force about some freaking line. In this case, it was DE. On your test, it won't be DE, it will be something else. AB, AC, DE, whatever. Next question. Hey, tell me the component of the moment about the same damn line. Notice the same damn line, DE, DE. Why am I doing the same line? Because I don't want you to spend your time finding a unit vector of a different line. You repeat the same unit vector that you did in question number C. And then the last part says, hey, take this system, reduce it down to a single force, single moment, and I'll give you the moment center. In this case, the moment center was C. We just did a problem like that today. We had 5 forces. We reduced it down to a single force, single moment, 26,500, 25,800. And then what's the rest of it say? Can the system be reduced any further to a single force or a moment? Well, shit, apply the litmus test. Single force down to a single moment. If that equals 0, we're in business. It goes down to a single force. If it's not, you just say, not reducible. Done. You move on. Well, if it is reducible, you got to do what we just did. We set the moments equal to each other so I can establish the location of that single force. So you'd have to give me x, y, z. In the problem we did, we only did x and z. Why? Because it was in the xz plane. I don't have a y. Here, it's possible I have a y. So you say x, y, z. Find me x, y, z. Now, I'm telling you right here, right now, this should be 10 out of 10 for this problem. If you don't get 10 out of 10, I guarantee you made a math error. You made a math error. because we have covered every single one of these A through E. And on the test, it'll be A through E again. No change. What has changed is the diagram has changed. That's it. The diagram has changed. That's the only thing you have to worry about. So you're going to sit there and say, well, question number 3, I wonder if he's going to ask me. Yes, he is. Whatever's there is on your test. So this should be 10 out of 10. And if you don't get a 10 out of 10, I guarantee you it's a math error. Or you didn't do any study whatsoever and you don't know how to do a scalar triple product. Or a projection of a force onto a line, which is a unit vector of the line dotted with the force. Or you don't know how to do an R cross F. I can't help you there. I showed it to you, now it's up to you to study it so that you can reproduce it on the test. It's identical. The only difference is the damn diagram. That's the first problem I would do. Because on any test you should take, the strategy is, let me grab as many points as I can. So if I'm you on the test, I'm doing problem number 3 first, I'm doing problem number 1 second, and I'm doing problem the second problem third. I'm saving that one with the pulleys and the blocks on inclines, and oh, it's a doozy too. You don't love it. I love it. Of course I created it, but that's beside it. Okay? Let me ask this question on problem 2. Do you think you'll have pulleys?
Yes.
You think you'll have blocks on inclines?
Yes.
You think you'll have to take a moment someplace?
Yeah. Babe. Yes.
Yeah, probably. You think there'll be springs in series?
Yep.
Springs in parallel?
Yep.
Do you know how to deal with springs in series, springs in parallel?
Yes.
If you don't, you better learn tomorrow because there's some shit on the test, on the quiz. But for sure it's on the test. Right? You can't sit there and go, I do know it. If you can't rattle them off the 3 things you should know about springs in series, springs in parallel, you don't know it. You don't know it. Right, Webster? We agreed to that, didn't we?
Yes, we did.
I said to him, in series, spring forces are additive. True or false? And he hemmed and hawed. No. You can't hem and haw. You can't sit there during a test or a quiz and go, let me see. No, it's got to come out like this. It's got to come out like you're breathing air. You think about breathing? No, you just breathe. Same thing with this. If you can't spit it out instantly, you don't know the shit. Well, I knew this stuff. No, you didn't. He said the same thing. Oh, I know it. Yeah. His first answer was dead wrong. I'm like, really? You know it? You can't sit there and during the test, especially an action-packed test that you're going to get, stop and pause and like, what do I know? Springs in parallel. Let me think. Forces are at no, they're the same. No, you can't do that. Literally, it is read the question, look at the diagram, read, react, and start writing. You can't pause and go, what do I know about springs in parallel? You can't do that. It's got to be instantaneous. You see it, you got to go boom, boom, boom. If you don't, you ain't ready for the test. You may think you're ready, but you're not. How do I project a moment onto a line? Unit vector of that line, dotted with R. R goes from the line to any point on action of the force, crossed with the force that's creating the moment. If you can't say it that quick, you don't know it. I hate to tell you. I know you think you know it, but you don't know it. There's one thing when I do it, you go, yeah, I get it. Then you go by yourself and try to do it and go, hey, let me look at my notes here. You don't have any notes on the test. You can't look at notes. There is no note looking. You either know it or you don't know it. And if you don't know it, you have to pause and think. I guarantee you, somewhere along the line, you're going to write to me, I ran out of time. And that's when I take my red pen, cross it out. Should have studied more. Usually that's what I write.
Yeah.
Or if I'm really pissed, I don't give a shit. I will literally write that on your test. I ran out of time. If I'm okay, I'm not stressed while I grade, you should have studied more. Or if I'm really angry because you guys are really doing poorly, I can see it. I don't give a shit. That's what you're going to see on your quiz or on your test. And sometimes, oh yeah, it happens all the time. I ran out of time. Should have fucking studied more. It should be 10 out of 10. I usually like to start with number 3, and when I grade, I turn all the papers over, and I flip the back page, and I start grading problem number 3. Then I go to problem number 2. That's when I get pissy. Because usually problem number 2 is the killer problem. And then I do problem number 1. Why? It avoids me looking at your name. I don't want to see your name. I want to base it on what I see, not your name. Everybody says, oh, Nora has favorites in his class. He gives them the better grade. I don't even see the fucking grades until I go to the first page and I write, then I look at the name. Other than that, I don't see names. When I assign the grades at the end of the semester, I take the final average, write them from highest to lowest, and I put in where the A's, B's, C's are. Then I associate that grade with the fucking name so I can put it in the grade book. Other than that, I don't look at names. So I love when people, oh, Nora just loves certain students get better preferential grades. Where do you guys get that shit from? Some of the shit I hear, I go, what? In the fuck are you guys talking about?